Okay, good morning students. Okay, welcome to the session. Now today's topic is design of control unit. Okay, what is a control unit? Okay, control unit means it is responsible for generating the control signal. Okay, what is a control signal? Control signals are used for transferring the data or information to the several register, between several register, or to transfer the information to the several register. Okay, mainly control unit helps to generating for controlling signals that transfer the information to several register. Okay, and also control unit manages the ALU, arithmetic logic unit. It performs all the computational operations. Okay, it also performs the ALU operations. It also performs all the computational operations. And control unit has two design issues. Okay, here the control issues has mainly two design issues. One is hardwired and second one is microprogram controlled. Microprogrammed controlled. Okay, for control unit, it is responsible for generating the control signals. It transfers the information to the several register, and control unit also performs the arithmetic logic operations and computational operations. It performs the computational operations, and control unit has two types of design issues. That is, first one is hardwired and second one is microprogrammed controlled. What is the performance of hardwired? The logic that can be implemented with the help of hardware components. The hardwired is a logic that can be implemented with the help of hardware components. What are the hardware components? Means decoder, encoder and flip-flops. These are the hardware components internally available in the computer. Next, coming to the microprogram control. What is a microprogram control? Microprogram control means it is a software or it is used for program. It is a software or a program. Microprogrammed control is a software and program. Okay, and control logic and signals are used to generate a program. Control logic. The program contains some logic. Okay, addition of two numbers, swapping of numbers. Okay, palindrome. Okay, these are the programs. The programs contain some logic. Control logic and signals are executed in the program. And coming to the microprogram control, it is a software or program. What is the definition of microprogram? Microprogram contains micro instructions or set of instructions. For every micro instructions has one or more operations. For every micro instructions has one or more operations. Okay, microprogram is nothing but set of micro instructions. That micro instructions contains one or more operations, like our program. Simply we use the C program, Java program, Python program. It contains set of instructions. That every instructions that contains the one or more micro operations. Okay. Here next, the control memory. The content of microprogram control always stored in the control memory. The CPU in internally that consisting of one memory. Okay. Every action that can be done with the help of microprogram control, that can be stored in control memory. This is about the just brief introduction about the control unit. Next, coming to the design of control unit. This is the internal part of the control unit available in the computer. Okay. Okay, it consisting of three fields. Here, F1 is one field. Okay, F1, F2 and F3. These are the three fields in the control unit. Here we have to take the 3/8 decoder. Every field that contains 3/8 decoder. Already in last class we see about the micro instruction code format that contains the field 1, field 2, field 3 and address register, data register and accumulator. Field 1, field 2, field 3 contains the 3 bits. Here the input is 3 bit. This is the input and 8 means output. Okay, here we have to take 3/8 decoder. Here 3 means input lines and 8 are the output lines. Here F1 contains 3 input lines. Here also F2 contains 3 input lines and F3 contains 3 input lines, and 8 means here the output lines are used for 8 lines from 0 to 7. Okay, here every field that contains 3 by 8 decoder, 3 means 3 input lines and 8 means 8 output lines from 0 to 7. Decoder 0 to 7. It takes the 0 to 7 output lines. And what is the definition of how you take the 8 output lines? Already we know the definition of decoder. What is a decoder? Here n inputs means, here n inputs means we have to calculate it with the help of 2 power n. Okay, here the input is 3. Here 2 power 3 means 8 output lines are performed for the implementation of the control unit. Here the decoder has a n inputs. We have to assume that there is a n inputs. Okay, 2 power n means here n inputs means 3. 3 inputs. We have 3 inputs. 2 power 3 is called 8. Here we have to take for every field 8 outputs. 3 are the inputs and 8 are the 3 are the inputs and 8 are the outputs. That's why we have to take the every field as a 3 inputs and 8 outputs. Okay, that's why we call it as 3 by 8 decoders. Okay, these are the 3 fields. Here we have for F1, we have 7. For F1 we have to take 7 outputs, 0 to 7 outputs. Here also to the F1 we have to take the 7 outputs. From F3 we have no made any connections to the F3 decoder. Here, okay, 0 is for the, okay, here in every operation, here we have to take 8 output lines, in that we call it as 0 to 7. For every field, for one operation is nothing to be performed. Here in F1, 7 is not perform any operation. Here F2, 7 is not performing any operation. Here F3, in total 0 to 7, it does not perform any operation. For field 1, F7 is not perform any operation. Okay, in field 2 also 7 is not perform any operation. In F3, okay, here 7 is not perform any. Here any one output line does not perform any operation. But in F3, another output line does not perform. It is used for further purpose. Okay, in every field, one output line does not perform any operation. But in F3, another output line also does not perform any operation. It is used for the further use of the reference or further calculation it will be done. Okay, next coming to the F1 decoder. Here we have to take, here for F1 field 3 by 8 decoder of 1 gives the input to the arithmetic logic shift. Okay, here we have 8 output lines from 0 to 7. So 1 in output line does not perform any operation. Here 1 has a input. That input is transferred to the, okay, 1 gets use the input to the arithmetic logic shift unit. Okay, here add operation is performed. Here 1 is a output of a decoder. Okay, arithmetic logic shift unit that gets the input from 1. Arithmetic logic shift unit that gets the input from 1. Here add operation is performed. Okay, for field 1 decoder. Field 1 field has a decoder. 1 gives the input to the arithmetic logic and shift unit, and arithmetic logic shift unit gets the input from 1 decoder. Okay, here we will perform the add operation. Here coming to the F2, here 3 is a gets arithmetic logic shift unit, logic unit gets the input from 3 decoder from F2 field. Here AND operation is performed. Here the AND operation is performed. Here AND operation means, for example, AND is denoted like this. Okay, already we know about the arithmetic logic shift unit. It performs the arithmetic operation, logic operations and also shift operation. What are the arithmetic operations? increment operation, decrement operation, add, subtract, multiply, division. Okay, these are the arithmetic operations. Next, coming to the logic operations, it consisting of logic operations has also some logical operations. Okay, clear, compare, exclusive or operation. Okay, these are comes from the logic operation. Next, coming to the shift operation, shift right, shift left. Okay, shift right rotate, shift left rotate. These are the shift micro operation. Okay, here 3/8 decoder use the, here 3 input use the input to the, 3 is a output line, 3 give the input to the arithmetic logic circuit. Here AND operation will be performed. Here remaining operations, here we have only 3 fields, F1, F2 and 3 fields. Okay, here F1 has 7 and F2 has 7 output lines. Here we have to take 0 to 7, here also 0 to 7, here also 0 to 7. For every field we have to take one output is used, does not perform any operation. Here also does not perform any operation. That's why you call it as only output lines are 7. Here 2 operations are not performed. One is for not perform any other operations and one is does not, it uses the further use. That's why you call it as 6 operations, 6 output lines for the F3 field. Here total 7, field 1 has a 7 and field 2 is 7 and field 3 is 6. Totally we have 20 output lines for those 3 fields. We have totally 20 output lines for those 3 fields. Out of 20 we have used only some operations because there is a confusion about their connections. Internally in the hardware we can implement those 20 connections in the control unit. Okay, here only we see the example of what are the connections, what is the connections are placed from arithmetic logic unit to the decoder, which field to which field they will connect it. Okay, here only 20 operations are performed. Field 1 has a 7 output lines, field 2 has 7 output lines. Out of 8 they can access only the 7 output lines, field 1 and field 2. Coming to the field 3, they can access only 6 output lines. 7 is not perform any operation, 7th operation, and 1 operation is used for further purpose. Okay, coming to the F2 field, it consisting of 3/8 decoder. For 3, use the input to the arithmetic logic shift unit. Arithmetic logic shift unit performs all arithmetic logic shift operations. Okay, it is uses the all computational problems. Okay, here coming to the F1 field, here 1 gives the output to the input as arithmetic logic shift unit. Here AND operation is performed. Okay, here the operation that can be performed with the help of arithmetic logic circuit shift unit, the information is placed to the accumulator. Okay, here the information placed in the accumulator. Accumulator is a general purpose register. It can perform some operation. Here, whenever the clock pulse is enabled, the load also enabled. Okay, the load will be transferred to the arithmetic logic shift unit to the accumulator. Here, for every clock pulse, the load will be enabled. Whenever the load will be enabled, the arithmetic logic shift unit has some content. That content is transferred to the accumulator. Okay. Here, this is a multiplexer. Okay, this is a multiplexer. Here, the multiplexer has 2 inputs from PC and from data register 0 to 11. Okay, this is from instruction format. Okay, 0 to 11, it coming from the multiplexer gives the input from program counter and also data register from 0 to 10. Okay, what is the definition of what is the purpose of multiplexers? It transfers the information from one end to another end. It transfers the information to the source to destination. Here the multiplexer get the information from the field 1 decoders to the multiplexer and then transfer to the address register where the memory is present, that is transferred to the address register. Here multiplexer has 0 and 1 inputs. Okay, 0 is coming from program counter and 1 is coming from data register. What is the program counter? It always holds the address of next instruction to be executed. it always holds, program counter holds address of next instruction to be executed. Next, this is a data register that coming from the 0 to 11. Okay, first next coming to the fourth one. Here field 1 has a 4 output line. 4 output line use the output output or in that can be input as arithmetic logic shift unit. Here DR, T means transfer, AC. Here the content of data register that is transferred to the accumulator. Here what operation is performed? The content of data register. Whatever data it may be, the content is placed in the data register that is transferred to the accumulator. The data register that can be transferred to the accumulator. Next, coming to the fifth output line. Here this is a data register transfer to AR. DR means data register, AR means address register. Okay, that is to selected to the multiplexer. That information is transferred to the multiplexer. Here PC transferred to AR. Here 5 and 6 are the output lines of field 1. Okay, here we have two types of operations. Here data register is source, AR means destination. Okay, here also program counter, PC means program counter, it always holds address of next instruction. Okay, source register. Okay, here AR means destination register. Okay, this is the source. Okay, coming the information from source to destination. Here also data register transfer the information to the address register. Here also program counter that transfer the information to the address register. Here for 5 operation is enabled. The data register is a source register and address register is a destination register. That information is transferred to data register to address register. Here 6 output line is enabled. The information of program counter. Program counter is a source register and address register is a destination register. The information that is passed to program counter to address register. Okay, here it contains the exclusive OR operation. This is an exclusive OR operation. Here load is enabled for every register, for every output line. Okay, the information that is passed to the address register. Okay, this is the address register. Okay, for every clock pulse, the timing signal is generated to the address register and also accumulator. Whenever the clock is enabled, the information of arithmetic logic shift unit that is transferred to the load control. Okay, the information of arithmetic logic shift unit, the information is that is transferred to the accumulator. Here these are the 3 fields: field 1, field 2, field 3. Every field has 3 inputs. Okay, here we have to denote it is a 3 inputs. F1 has 3 input, F2 has 3 input and F3 has 3 inputs. Okay, in that we have 8 decoders. Why you take the 8 output lines? 8 decoders means 8 output lines. Here the input is 3. For every n inputs, we have to take 2 power n outputs. Okay, here n means 3. We have to place 2 power 3 means 8 output lines we have to take for every field. Okay, from 0 to 7 it places the 8 output lines. From 0 to 7 it takes the 8 output lines. Here also 8 output lines. Here for every field one does not perform any operation in every output. In every field one output line does not perform any operation. And for F3 one is used for future purpose. Future purpose. Future purpose. Okay. For every operation that can be used for here we have for every field has 8 output lines from 0 to 7. Okay. This is about the field 1 and field 2 and field 3. Here for field 1 has only 7 output lines are enabled. Field 2 has 7 output. Out of F3 has out of 8 outputs we have output lines we have used only 6 output lines. That's why totally we have only 20 output lines. Okay, for internally they can utilize 20 output lines of decoders. For our explanation, it is very clumsy. For internally we use the total 20 output lines of decoders we use in the internal design of the control unit. Okay, now only we have to explain it what is what, which for which field, how many output lines are enabled. For every output line, what is the operation is occurred, that is explained in this video. What is the design of control unit? Okay, here coming to the F2, 3 gives the input to the arithmetic logic shift unit. Here they performs the AND operation. Here coming to the 3/8 decoder of F1, 1 gives the input to the arithmetic logic shift unit. Arithmetic logic shift unit get the input from one F1 field, one output line of F1 field. Here the 4 is enabled. Okay, that is here the 4 gives the input to the arithmetic logic shift unit. Arithmetic logic shift unit gets the input from 4. Okay, here the operation is performed data register that can be transferred to the accumulator. This is a source register and accumulator is a destination register. Here 5 is, whenever the 5 is enabled, 5 gives the input to the multiplexer. Where 5 is selected, then the information is given to the multiplexer. Here the data register has some content and address register has some content. Data register is the source and address register is the destination. The information is that is transferred to the data register to the address register. Here also, whenever the 6 output line is available of the field 1, okay, the program counter is a source register and AR is a destination register. The data of the program counter that is transferred to the address register. Here the load is enabled, that is transferred to the address register. The information is transferred to the address register. Here 5 is enabled, the data is transferred the data register to the address register. Here program counter is enabled, the program counter information is transferred to the address register. This is the figure name is decoding of micro operation. This is a decoding of micro operation fields. Here they contain 3 fields, F1, F2 and F3. Decoding of micro operation fields. It consisting of arithmetic logic shift unit. Already we discussed detailed in earlier class what is the arithmetic logic shift unit. Okay, here the accumulator and multiplexer, address register. Okay, these are the 3/8 decoders. Okay, these steps are just simply about this decoding of their micro operating fields. Okay, the 3 decoders are some of the connection that must be made from their outputs. Each of 3 fields of micro instruction presently available in the output of control memory that decodes the 3/8 decoder. Okay, here we use for the decoding micro operation, we use 3/8 decoder to provide the 8 output from 0 to 7. Already we use in the decoding of micro operation. The arithmetic logic circuit unit also designed instead of using gates to generate the control signal marked by the symbol AND, add and data register. Here we use the 3 type of operations mainly, AND, add and data register. Okay, here the microprogram sequencer also occur. The basic components of microprogram control are control memory and the circuit is selected to the next instruction. Already we discussed it in the microprogrammer control topic. Next address generator is also known as a sequencer. What is the sequencer? The sequencer is nothing but we have to transfer the micro instructions to the next automatically. Whenever the CPU is executed the next instruction, automatically it can be transfer the information or executing the next address generator with the help of the sequencer. Okay, this is known as a microprogram sequencer. The basic components of the microprogram control unit are the control memory and circuits are selected the next address. This is known as a microprogram sequencer. Okay, microprogram, whenever the CPU is executing the instruction, then simultaneously it also instructs the next instruction to be executed. That is known as a next address generator, and it is also called as a sequencer. Okay, this is about the design of control unit. Okay, what is a control unit? Control unit means it generating and it is also responsible for control signals. Okay, control signals are responsible for to transfer the information to the several registers. It also responsible for ALU, arithmetic logic unit, and computational problems. Okay, for mostly control unit can be designed two types, hardwired and microprogrammed control. Hardwired means it is a logic which can be implemented with the help of hardware components such as flip-flops, decoders and encoders. Microprogram control means it is a software or a program. Microprogram is a set of instructions, and set of instruction contains one or more operations. Okay, whole operation of microprogram control is stored in the control memory. Okay. Okay, coming to the diagram, it consisting of three fields. It contains 3 inputs and 8 output lines. That's why we call it as 3/8 decoder for every field, and it contains 8 output lines. These are the operations that can be performed in the control unit. This diagram is known as decoding of micro operation fields, and it contains arithmetic logic shift unit. It is the accumulator, multiplexer, address register. Here out of 20 for F1, F2, F3 has totally 20 output lines. For every 20 the internal parts of the computer that can be utilized all 20 output lines. Just we have to view what are the input lines, which output lines are performed these operations. Okay, next class we discussed about the next topic. Thank you.